Hello everyone, welcome to the channel. After learning about the operations on sets, in this video we will discuss about the laws or properties on set theory. And the first one here is idempotent laws. What are idempotent laws? The idempotent laws are two. First one is on union of sets. That is A union A is equal to A. We can very easily understand A union A means the elements in A or in A. It means all the elements of A, and that is A itself. Second one is A intersection A equal to A. The intersection of two sets we know contain common elements, and since all the elements of A are in A, that's why A intersection A will be equal to A. The second one is commutative laws. There are also two. First, on the union of sets, that is A union B equal to B union A. A union B means the elements which are contained in A or in B, and that is same for B union A. The elements contained in B or in A, it means they will be both equal to each other. For intersection, we have A intersection B is equal to B intersection A, because the common elements in A and B, or we say B and A, is same. Next are associative laws. There are also two. One on the union of three sets and then on the intersection of three sets. First one is A union B union C is same as A union B union C. And the second one is for intersection A intersection B intersection C is same as A intersection B intersection C. And then the next laws are distributive laws. There are also two. The first one is A union B intersection C is equal to A union B intersection A union C. This is known as distribution of union over intersection. The second one is A intersection B union C is equal to A intersection B union A intersection C. And this is known as the distribution of intersection over union. We have also learnt about the complement of a set, that is A dash or AC, and it is known as difference of union and the set A. A dash is equal to U minus A. The elements which are in U and not in A, based on that is involutory law, that is A dash dash is equal to A. It means complement of a set is the set itself. Some of the laws we have also learnt along with the theory or concept of these operations. Next is De Morgan's laws. There are also two. Number one is A union B dash complement of A union B is equal to A dash intersection B dash. That is intersection of complement of A and complement of B. The second one in this is A intersection B dash complement of A intersection B is equal to A dash union B dash, that is equal to the union of the complements of A and complement of B. Next is complement laws. Complement laws are actually based on the complement of sets. Number one we have is, if we want to take the union of A with A dash, that will be the universal set U, because all the elements of A and all the elements which are not in A but in U are combined, and that becomes universal set. Second we have here is A intersection A dash. We can understand that A intersection E dash means A and A dash having any common elements, but there are no common elements in A and A dash, and that's why it is equal to phi. The third law here is phi dash, the complement of empty set. Empty set means not containing any element. and the dash of that means complement of that will be equal to U, that is universal set. And next is the complement of U, complement of universal set. Complement of universal set means U minus U, and that is equal to empty set not containing any elements, so this is equal to 5. Next are identity laws. What are these? They are based on the identity. What we have, first one is A union phi. If we make the union of A with phi, the empty set, that will be equal to A only or not? Yes, it is. Because all the elements of A, and this is having no element, so this will be equal to A. Second is A intersection phi. A intersection phi means common elements in phi and A, but phi does not contain any elements, and that's why there will be no common element in this, and that will be equal to phi only. Next is A union U. If we make the union of a set A with the universal set, it will be equal to U, that is universal set only, because all the elements of U will be coming in that. And the next is A intersection U. Since A is a subset of the universal set, all the elements of A will be contained in this, so this will be equal to A only. These are some of the laws on the operations. Now we will be learning some of the laws on the number of elements in the sets. We have already learnt about representation of number of elements of a set. Suppose there is a set A, then number of elements in set A is represented as NA. And here we have some of the laws based on this number of elements. NA union B means number of elements in A union B. We can find by the formula of the identity NA plus NB minus NA intersection B. Then the number of elements in A dash, the complement of set A, can be found by NU minus NA, the number of elements in the universal set minus the number of elements in set A. NA minus B, we have learnt in the concept, in the theory also, in that video, and according to that we can find NA minus B will be NA minus NA intersection B, because we also know that A minus B is equal to A minus A intersection B. NA union B union C, in case we want to find out the number of elements in the union of three sets A, B and C, that can be found by NA plus NB plus NC minus NA intersection B minus NB intersection C minus NC intersection A and plus NA intersection B intersection C. And for the number of elements in A union B, as we have learnt here, is NA plus NB minus A intersection B. We can also find the same by using the formula NA minus B plus NB minus A plus NA intersection B. Why? Because we know in the Venn diagram, as we know, if this is U, this is A and this is B, this is A and this is B. We know that this particular one represents A minus B. This represents B minus A. And this one represents A intersection B. If we add the number of elements in A minus B and B minus A and also in A intersection B, will we find all the elements or number of elements in A union B or not? So we can also write NA union B as NA minus B plus NB minus A plus NA intersection B. In the next video, we will be learning about some of the applications of sets. There will be some problems on the sets we will be discussing here. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.